Hello everyone, a very warm welcome to this video. In this video, we are going to talk about high availability. What exactly is high availability? Well, the end goal of this particular lab or video is if one name node goes down, other node comes up. So let's see what we are going to do in this particular lab and then we'll start executing the commands. So as of now, we have 4 machines. The machines are these are the 4 machines. Now on Delhi we are running name node, data node, node manager, Hive server, Impala server. When it comes to Mumbai, we are running secondary name node, node manager, and just Impala server is running. When it comes to Kolkata, what we are running is resource manager, Impala state store. That's the scenario. The end goal of this particular lab is we want to replace standby name node, secondary name node with standby. When we say standby, what we want to really demonstrate in this particular lab is as soon as one name node goes down, other takes over. That's the real agenda. And this could be done by implementing high availability. We've already seen high availability in theory. Here we are quickly going to reiterate what is high availability, and based on that we will start our lab. So let's get going. So out here we have, or we will have, name node which is running on a server called as now we will set up standby name node which will run on so we have name node that's running on Delhi, and we'll have standby name node that is running on, or that will be running on, Mumbai. Now, if the end user was to request or write metadata of name node, we also have to ensure that Mumbai also gets that update. And that is done with the help of journal nodes. And journal nodes are running on or will be set up on Delhi, Mumbai, Kolkata. So it's Delhi, Mumbai, and Kolkata. Now, to talk to to talk to the node managers or the journal nodes, on name node what we will also be running is journal manager that will interact with these nodes. This journal manager as of now will be writing, and this journal manager will be reading. Now, so far we have name node and standby name node, but so far we still don't have the failover. And for automated failover, we will have a set of 3 zookeepers. And to give heartbeat to zookeeper on every machine, we will run zookeeper failover controller explained in the theory. And zookeeper failover controllers will continuously ping So this is the setup that we are going to have, and zookeeper is already running because we have set it up in the Hive exercise. Running on Delhi, Mumbai, Kolkata. Delhi, Mumbai and Kolkata. So this is the end goal of our lab. By the end of it, what we'll have is we'll have these services running on each and every server. So let's get started. We will start by first shutting down all the services that are not required. Stuff like U, Impala, Hive, we will just move them out, and later one by one we'll bring up the whole thing. So let's get going. So let's start by stopping Metastore on Delhi. Let's verify that it's all clean. So you see that it's not running. The next thing is we have to stop Hive server 2. So let's stop Hive server 2. So we've stopped Hive server 2. The next thing is to stop Impala server on all 4 machines and stop Impala catalog and state store on all the 4 machines. So let's do that right now. So it will be sudo service Impala server stop, sudo service Impala server stop, sudo service Impala server stop, sudo service Impala server stop. And on Kolkata, we should also be stopping the catalog server. And we should also be stopping the Impala state store server. So that ensures that we have stopped all the Impala and Hive services. We stopped the Metastore, we stopped Hive, we stopped Impala. The next thing we are supposed to stop is U, because we are not needing U right now. So let's stop U and Hadoop HTTPFS on Chennai. So Hadoop HTTPFS is stopped. And the next thing is stopping you. So this kind of ensures that all the cleanup is done. So right now we have a bare working cluster that only has HDFS and YARN, nothing else. Now it's time for us to take a backup of our configuration, and then we will start changing the configurations. So let's make a backup. Let's make a backup of our configurations. So we've done a backup. It's time for us to now stop all the services that are running so that we can make the modification. So let's stop all the services and let's make the modification. So data node is stopped. Let's stop name node and secondary name node. So we've stopped secondary name node. I'm making spelling mistake. It's secondary name node stop. So we stopped all the services. So name node is down, data node is down, secondary name node is down. We've also brought down HTTPFS, Impala, Hive, and Hive Metastore. The reason to bring HDFS down is because we are now setting up name node availability. So it's our job to first stop it and then change the configuration. So let's understand what configurations are we trying to really change. So far, it was all about one name node and everybody would simply point to that name node. But right now that's changed. Now there are two name nodes. So we will have to educate the cluster that yes, there are two name nodes right now. And we'll have to tell everyone that yes, these are the two name nodes, that is Mumbai and Delhi. And we'll have Delhi as the active cluster and finally make sure that we are able to perform a failover. So let's understand how does that work. So we'll have to go to each and every configuration. In the code side, there'll be no name node right now, but an alias called as my cluster. So all the clients will hit the my cluster, and my cluster would basically translate to which one is active. Next, your zookeeper thing would be, or zookeeper quorum would be in code side.xml. In HDFS side.xml, we'll have to translate that my cluster is nothing but name node 1 and name node 2. Name node is Delhi 8020, Mumbai is Mumbai 8020. The web address for Delhi is Delhi 50070 and the web address for Mumbai is Mumbai 50070. The shared location where data would be written would be Delhi, Mumbai and Kolkata. So these are our journal nodes. What path will journal nodes write their data is basically disk1 DFS JN. There is a Java class that provides us a failover functionality. That's the class name. And what if one name node goes down? What do we want to do? We want to immediately, let's say, shut that down, for example. So there is a fencing method and we want to enable the automatic failover. So these are all the settings that we have to add in core-site.xml and hdfs-site.xml. Once we do that, we'll have to copy these configurations on all the machines. So let's first do that, and then we will move our focus to the journal nodes. So here we have core-site.xml. The major change we have to make right now is fs default fs should be hdfs my cluster and quorum zookeeper name. So let's have fs default fs and leave rest of the settings. So we'll not touch any of these settings and have them the way they are. So let's first quickly talk about, let's quickly change fs default fs to my cluster only. So it will be hdfs hyphen my cluster. hdfs hyphen my cluster. Next thing we need to educate core-site.xml is the fact that it's HA zookeeper quorum. And in zookeeper quorum, we'll have to educate name node that the zookeeper is running on Delhi, Mumbai and Kolkata. So let's do that. We'll have to specify it's Delhi, Mumbai and Kolkata. Once we do that, we'll have to copy this configuration on all the three machines. So this is our way of letting the name node know that, or letting the core-site.xml know that this are our settings. So everybody will now hit to my cluster and the zookeeper quorum is Delhi, Mumbai and Kolkata. Next, we'll have to copy this configurations in every machine. So here we have fs default fs and zookeeper quorum. It's perfectly fine. Here we've educated core-site.xml. All right. Now all the machines know where exactly is the cluster. The next thing we need to do is change the hdfs site.xml and put all the settings, and then copy all the settings across the cluster. So let's do that right now. In here, we are not supposed to touch any of the setting. We are just supposed to add the new settings. So let's do that. So let's take a property tag. So in property, DFS name services and my cluster will be the value. And the value would be my cluster. So we've done our first setting. Let's do the rest of them. The next one is DFS HA name nodes my cluster. We'll have to say name node 1 and name node 2. So it is DFS HA name nodes my cluster, and the values will be NN1 and NN2. So that's 2 nodes. Third is DFS name node RPC address my cluster.nn1. This is our way of telling that where is name node 1 running. It's running on Delhi. It's running on Delhi. So let's change. So it is DFS name node RPC address my cluster NN1. And here the value should be Delhi 8020. So we have Delhi 8020. The next setting would basically talk about the name node 2. So here it is Mumbai 8020, and just to be sure, change this name node 2. So here we are with our name node 1 and name node 2 changed. The next setting that we are going to talk about is the web address, the HTTP address. And in there, Delhi 50070. So that's Delhi 50070. In here, we are talking of the web address of name node 2. And here it is Mumbai 50070. Next is the shared directory setting. So let's quickly kind of have so let's take so we've now set up the journal port numbers. Basically, these are the ports where Quorum Journal Manager will, Quorum journals will basically accept the metadata. The edits directory for journal nodes. So let's put this directory here. And the next setting is going to be and we'll have to give the class name that provides us failover. Alright. So at this moment, we've done certain settings. Let's first copy them before we add further settings. Alright. So these settings are copied. There are a couple of more settings. We'll put them. First, let's put this one. And let's go to the Chennai machine and do that. Okay. On all the 4 machines, these settings are copied. It's time to add last 2 settings. So let's put last 2 settings and copy them everywhere. Okay, so these are the 2 configurations. Let's put them. First is about fencing method, that if one node goes down, what is it supposed to do? We would prefer to have it shut down. And the value is and the next one is the value is true. It's now time to copy these 2 configurations. Okay, let's copy this in. So it's done. The next is Kolkata, and after Kolkata it will be Chennai. So once we have Chennai, it's all about starting services, and we'll have our high availability setup done. Here we go. All right. So as of now, all the configurations are successfully copied on all the machines. Now it's time to install journal node, create those directories, and then we'll start the services. So let's install journal node on Delhi, Mumbai, and Kolkata. So we've installed journal node. Let's copy this command on Mumbai as well as Kolkata. So we have journal node getting installed on all the machines. So now that journal node has got installed, let's create the directory. Should be disk1 dfsjn and not home. So that's a typo. We should give the permission to HDFS user for disk1 dfs journal node, and this should be repeated on every Once we are done with this, it will be time to start the journal node. So let's start journal node, and then we will initialize the shared edits. Journal node has to be started on 3 machines. Journal node start. So looks like journal node has started. To verify it, the command is jps, and what you should see is journal node. The journal node should have got started. The journal node should have got started. Let's start journal node on this machine. And should run a jps command. Journal node is up. and we should see journal node. So all the 3 journal nodes are up and running right now. The next thing we'll have to do is we'll have to initialize shared edits. That means the metadata that name node already has to be copied to the shared location so that the other standby name node can get initialized. So here what we run is initialize share edits on tele, and if that runs successfully, it will be time for us to start the name node. So looks like everything has got successfully in, and it's time for us to start the name node. So let's start the name node. If name node starts successfully, we are sure that one of our name node is up. We will have to check its status and it will still be in standby mode. Then we start the other name node and this will become active. Let's look at that right now. Let's look at JPS. So it shows name node is up and running. So far it's good. Next thing we'll have to do is we'll have to get the status of the name node 1, and this should show us standby. This should show us standby. So we see that first name node is still standby. Now we'll bring up the other name node, and once we bring up other name node, we'll install failover controller and we will have a proper failover working. So let's start other name node. So it's name node which is up. Let's start this name node and get the status. Even this will be standby. So what we get here is standby. So at this moment, both the name nodes are up, but they both are standby because we want to set up Zookeeper failover controller, and based on that, one will be elected as active. So let's do that right now. Install Zookeeper failover controller on both the machines, and on both the machines, format it and start it. So Zookeeper failover controller is installed on both the machines. So right now on the name node we have journal nodes, and now we have installed Zookeeper failover controller. It's time to format Zookeeper controller and start it on both the machines. On both the machines we'll have to format it. And start it. And then we start the Zookeeper failover controller. Let's run. What we see is that failover controller is up. It's time to start failover controller here. and run the JPS command. So what we have is failover controller on both the machines. It's time for us to get the state of each machine. What we see is the first name node is active, and run name node 2 state, and you will see this has to be standby. Let's quickly explore the UI for both of them, and then we will practice failover. So we go to Delhi 50070, and this happens to be active, and Mumbai 50070 happens to be standby. So at this moment, our Hadoop cluster is completely highly available. If one goes down, other will come up, other goes down, one will come up. So let's practice that first up. So we say sudo service Hadoop HDFS name node on Delhi. We stop this, and immediately this becomes active. So going to the browser, first one will not load, and second one suddenly is active. So this is how you see that if one goes down, other takes over. Let's start this once again. Now both the name nodes are up. Here it is standby, and this is active. It's time for us to now start data nodes on all the 4 machines. So on all the machines, data node is getting started. What see here is all the 4 data nodes are up and running. So this was high availability in Hadoop. We've seen how one goes down, other takes over. This is high availability in Hadoop. So this is what we've done for high availability. Now that we've seen high availability and we've seen the fact that one goes down, other comes up, let's quickly summarize what we've done so far. So step 1 was to stop Hive Metastore. Hive Server 2 and Impala. We stopped U and HDBFS. Step number 2 for us was to bring down name node and data node. Step 3 was to update the configs. So we went ahead and changed codesite.xml and hdfs-site.xml. In hdfs-site.xml, we mentioned about two name nodes. We mentioned about the shared locations. In step 4, we installed and started Zookeeper. We did not do this because we already had it from Hive. In step 5, what we did is we installed journal nodes. Step 6 was to initialize shared edits so that one name node's edits that we had should become common right now. Step 7, we started name node. Step 8, we bootstrapped standby name node. Step 9, we started another name node. Step 10 was that we installed and formatted Zookeeper failover controller. Step 11, after we formatted the Zookeeper failover controller and started it, was to verify if name node and standby were failing over. Step 12 was, so we verified if name node and standby was failing over, then we start all data nodes, verify the UI. So this is what we have done so far in this particular lab. This was the last video in this series of manual installation of lab. So let's quickly reiterate what we've done so far and the next step for these labs. So for administration course lab series, lab 1, we acquired 4 machines on Amazon and installed Hadoop cluster. In this lab, we purchased 4 machines. We started an entire cluster with Mumbai, Delhi, Kolkata and Chennai, and we had a working cluster. In lab 2, we set up Hive and Impala. In lab 3, we set up U. Lab 4, we set up high availability. Now, all this lab setup that we did so far could also be called as manual setup, where we rent machines, we install each and everything, we set up things manually, and we bring up high availability. The lab 5 will be cluster setup using Cloudera Manager. This will be a complete setup which will be automatic with the tool called as Cloudera Manager. So let's look at that in the next video. So that brings us to the end of this lab series where everything was done manually. Purchasing machine, installing Hadoop, installing Hive and Impala, installing U and setting up high availability. And in the next lab we will see how to do Cloudera Manager setup. Now we will gracefully shut down these machines and terminate them from Amazon, and we'll be off. So now it's time to visit Amazon. In Amazon, click on Amazon EC2. In here, click on 4 instances and say terminate. And this would terminate all the 4 instances of your cluster. So the cluster is completely destroyed, and from here on there is no need to pay for these machines. Once it's done, click sign out. And on the side note, there are 4 volumes or hard disks, as they say, EBS volumes, that also have to be deleted. So they are still in use. Once they become available, we can delete them. So one is available. Let's wait for all of them to become available. While all 4 are available, we simply have to say actions, delete volumes, and all the volumes are deleted. So this was all about setting up cluster manually on Amazon. What you need is an Amazon account, you need a valid credit card, you purchase CentOS 6.5 machines, log into them, install Hadoop, install Hive and Impala, install U, and set up high availability. That was the agenda of this lab series. In the next lab series, we will set up this entire cluster, but with the help of a tool called Cloudera Manager, where all you need to do is a wizard driven approach of just click, 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 and it will be done. Thanks for watching this video and this series. Thank you.